Hey guys, time for another unboxing video. Now I know what you're thinking. What could I possibly want? What could I possibly need? Don't I already have enough stuff? Maybe not. So what this is, well, you may recall I took the plunge and got a spectrum analyzer. I think it was last year, or was it the year before? A vintage one. And I got it working, and it ended up being surprisingly easy once I realized what I needed. I was missing the cables, I was missing the crystal oven, went through the calibration procedure, and basically it's working. However, there is a companion piece to it that I am missing that will hopefully greatly increase its usefulness to me. So what I currently have, it's spectrum analyzer, which is like a police scanner on steroids. You can select a start frequency and a stop frequency, and it'll scan the input for that range of frequencies of interest. I demonstrated it with just hooking up an antenna and just pulling out whatever's in the air over that frequency range, and I was actually able to pick up some AM stations and such. You can also feed in a signal from, say, a circuit you're working on, or you can get probes and you can wave them around something and you can see, is something radiating RF where it shouldn't be? Are there harmonics where there shouldn't be? Is a filter working right? However, it just is a passive device. It's just receiving whatever's out there, or whatever you feed into it. What I mean by passive is, I mean, of course, it's running on electricity, but what I mean is, it's not generating any signals of its own. It's just detecting whatever you feed into it, like an oscilloscope. However, there is a companion piece that does generate a signal, and it will be in lockstep with the spectrum analyzer as it's scanning frequencies. So imagine you're scanning from 1 megahertz to 10 megahertz. There's something called a tracking generator. So as it's listening for 1 megahertz to 10 megahertz, the tracker puts out 1 megahertz to 10 megahertz. Now, why would you want to do that? If you put the output of the tracking generator to the input of the spectrum analyzer, it should be a flat line over the frequencies of interest, because you're just putting out a steady state signal. While the magic is when you put something in between the output of the tracking generator and the input of the spectrum analyzer. What you're doing is making a sleep generator, like you would use for an alignment. However, you'd say it's on steroids because it's just far more precise, has a bigger dynamic range, more accurate than your typical sleep generator. Now, I've also got a nice one with an HP8444A, which I also had to do some repairs on and restore. And that works fine, although when I used it with my scope recently, I found out that the markers aren't working quite so right because the Z-axis intensity modulation on my scope doesn't appear to be working. But anyways, ever since I got that spectrum analyzer piece, people have been sending me notes saying, hey, you should really get a tracking generator and see if you can do an alignment with it. Well, here we go. Now, there are spectrum analyzers that have built-in tracking generators, but this is not such a device. And I intentionally got an older spectrum analyzer. You can get, heck, there's a tiny SA now that's like a little postage stamp size device. But I like the vintage stuff. I like stuff that you can actually see the individual chips and you could repair it if need be. It's modular, and there's a really nice service manual and all that. Whereas everything nowadays, of course, is surface mount and nearly impossible to repair. Trade-off, of course, being that this stuff is huge. So anyway, this is the tracking generator. Now, these are not uncommon by any means, and I've been keeping my eye on eBay for one, and I like to gamble, so I got one at a discount because it's listed as not working. It's also not the one that most people will tell you to get, which is, I think it's option 59. Spectrum analyzer I have goes up to 1.5 gigahertz. This one goes up to 1.3 gigahertz. The option 59 extends the range up to the full 1.5. I don't care because I don't work on anything at that high frequency rate. So I was able to save quite a bit by getting one that was not working and doesn't have that option. Now the seller says you push it and the power light comes on while it's depressed and doesn't stay on. That is my best kind of problem to see. Either it just flat out doesn't do anything or it doesn't stay on. Because often it's just a power supply issue. It could be something simple. It could just be a flaky on-off switch. I've seen that with some scopes. Just had to exercise a switch or clean it with some deoxit and there you go. It could just be a burned out fuse. It could be some leaky caps in the power supply. What I really don't want to see is when something turns on and kind of works, because then you're into troubleshooting mode. You get out the service manual and you got to go through all the modules and all that stuff. So fingers crossed it's something simple. If it's not, didn't spend a ton of money on it. And hey, it was free shipping, which is another bonus. Now I've never looked inside one of these. I don't know anything about them. All I know is that you connect some of these up to the spectrum analyzer and that's how they stay in lockstep. Not a whole lot of controls. You got your RF out, level, tracking adjust. There's a manual. There we go. Great frozen control. Then there's a manual scan. I'm thinking if you're in manual mode, this is just an RF generator, although going from 0.5 to 1300 megahertz with just a single turn knob, it's got to be impossible to get any accurate frequency out of. So third LO input, first LO input. I'm pretty sure that taps into some of the phase lock loops on the spectrum analyzer. Kind of odd that they're on the front though. Let's see what we got on the back. Sticker that it's been set for 120 volt operation. The third LO input. Okay, so we have two inputs on the front and one input on the back. I got to see exactly how this connects to the spectrum analyzer. I hope it's not too crazy to route the cables around. And then there's an auxiliary RF output with a 550 ohm terminator on the back. As I said, there are no options installed on this. All right, let's start out with the basics and pop this open and try to plug it in and turn it on. Should be able to turn it on and just do a basic power up test without it being attached to anything else. Now these may look like Phillips head screws, but they are not. I have my special PZ 1-bit installer, and that should be all I need to do. The top just slides off. Or not. What's going on? I think it's just hung up a little bit. There we go. Just had to find the right place to push. Oh yeah. Well, look at that. Yeah, not a whole lot of user serviceable parts in there. Beautiful, lovely RF engineering. So you got a bunch of sealed high frequency modules. Very easy looking bandpass filter, 2 to 3.4 gigahertz. Wow. I have no intention of delving into any of those. Then there's power supply, which we may delve into if we need to. There's a little power transformer here, a couple big old electrolytics, and a couple power supply modules, and a couple power transistors mounted to the metal here. And well, that's basically all there is. So let's just plug it in and try to turn it on, right? I mean, heck, for all I know, the reason it didn't work for the seller is because maybe you do need to attach it to another device, or it just doesn't power up properly. Alright, I got it plugged in. So here we go. Light, let go, because okay, that's exactly what the seller was saying. Does not want to stay on. Curious, there's a dot and looks like an L on the side of the switch. Now, I don't know if this is supposed to be a push-on, push-off toggle switch, or you push it on and it's momentary and it activates something in this, and maybe there's like an overload, or some type of protection device that's sensing a problem and it's shutting it down, or is it a dirty switch? Now, if you're wondering why the heck am I powering this up here, not on the workbench is filled with projects, and I really need to finish them before I can delve into this. But we can do some basic stuff up here. Should also mention, even if I get this working perfectly, in conjunction with my spectrum analyzer, there is one other crucial device I will need. So the spectrum analyzer I have has some fantastic specs for the noise floor and the sensitivity and all that, but that comes at a price. So the front end of these spectrum analyzers, or the heart of them, is a mixer, where you're mixing the local oscillator to the incoming signal, and you're taking the difference and going through an IF like a radio does. There is nothing between the input and the mixer, which has some very sensitive diodes. I think it's a diode ring mixer. There's no amplifier, there's no attenuator, it's just going right into it. So it's really easy to fry. You cannot have any DC offset. You have to keep the amplitude below a certain level. Well, heck, if I'm going to be poking around a TV, there could be hundreds of volts of DC, there could be a really large signal. So I need to use a probe that can block DC, that can amplify or attenuate as needed. Now, of course, they make those. I just need to find one that's appropriate and use it with this. Likewise, I might want to do something on the output of this. The output of this should be a bit more rugged than the input, but I wouldn't want to fry this either. So, time for some research. Time for a little light reading. Now, luckily, Agilent has scanned and made freely available many manuals for their older test equipment. Now, earlier I had searched for just HP8444A manual, and I downloaded one, but in hindsight I realized that was an older edition. This is the latest, which includes option 59, and it's from 2004, which is decades after this device originally came out. And that 59 option in the later publishing date is going to be important as we see. See, I was under a false assumption that Hewlett-Packard never made an official tracking generator for my spectrum analyzer. Part of that comes from watching Curious Mark's video, where he points out that the 8444 predates my spectrum analyzer, but they updated this tracking generator throughout the years such that it not only can work with the 8568, but they show how in this manual at the end. Yeah, the cabinet styling isn't quite the same, and they don't fit together quite perfectly, but absolutely they can work together. Now, I've also been reading up on the theory of operation. So there is one fundamental problem with my unit, which does not have option 59. To use this, you need to supply two signals from your spectrum analyzer. The first local oscillator and the third local oscillator. And if you look at the 8568, it only has an output for the first LO, not the third LO. So what do you hook it up to? Well, my first thought was, hey, I don't need to do the full upper range, frequency range, so maybe you can get away with just the first LO and it'll work. And maybe it will for a portion of the range, but the official documentation says, yeah, you need it. So I've been reading through this. This is the operator and service manual, so there's a lot of stuff about hooking it up and performance tests. Later on, let least I think it's in this manual. Yeah, we get the service info. So there's a list of all the replaceable parts and some block diagrams, some schematics. In particular, here is the line on-off switch and power line module. So I was wondering about that switch. Like, is that a push on, push off, or whatever? It looks like it is a momentary push button, or latching rather. So here's our line coming in, or fuse, and there's the switch contacts. So it looks like you should push this, and then it locks in and supplies power through here. And here's that light. So it is still not. It is still possible that I just simply have a dirty switch contact. Because I would think if there's something downstream that is like, say, shorting out or something, and blow that fuse. Also notice this light that's inside the switch operates simply when this is closed. It completes the circuit. I think it's a neon bulb. So forget about what's going on down here. If you just close that switch and it's making contact, that light should go on. And when I let go, it goes off, which makes me think this is opening up. It's not some safety circuit down here disconnecting power. There is no, the only safety device from the line through the bulb, I believe, is that fuse. Well, let's see what goes on the other side of it, though. Maybe I'm wrong about that. Oh no, that's simply the line module. We can switch from 115 to 230 operation. So yeah, that could be that simple. Maybe it just sat for decades and that switch contacts got oxidized. So I was also thinking, hey, maybe it's not working because I don't have it hooked up to anything, and maybe it's sensing that and it's just shutting it down. I don't know. We'll find out in a bit. So we keep going on and on and on. We get theory operation, troubleshooting, schematics, block diagrams, and finally, way at the back, there's even theory of operation on the power supply if we need to go there. Some modifications, replacing. Here's option 58. And finally, we get to option 59. Now, one thing to note about these, I saw there was somebody listing this on eBay. Here, I'll show you what I mean. All right, I was thinking worst case scenario, if I really want to have one of these, I could buy a second one, and hey, I'd have this unit for some replacement parts. Because notice, hey, there's somebody selling one here. It says option 59, 219 bucks plus 35 shipping, and not horrible. But let's take a closer look at this listing. So it's a little beat up, it's a little scuffed up. So I was thinking, hey, if I bought this, I could swap parts between the two and make one good one. However, it says option 59, 1500 megahertz, but what does the device itself say? 1300. And furthermore, let's look at the back of this. I believe they have a photo showing the back of it. Yeah. There's one BNC connector here. Let's flip back to the manual. Well, what do we see? 2. When you get the factory installed option for this, it will have an output back there. And that's a loop back connector, typically. That's what they're showing here. So here's the deal. So I said you need to hook this up. There's 2 inputs on this. First LO input and third LO input. The 8568 only has a first LO output. So what do you put to the third LO input? Well, this modification includes a module. It just feeds back itself, so you don't have to feed an external signal in. Furthermore, it appears all that signal is a fixed 500 megahertz sine wave. That's it. It doesn't vary, it doesn't change with the device. And that module is just a really simple 2-transistor oscillator. I believe that's a schematic for it. Yeah, it's a little hard to read. It's sideways here, but this is it. This is all that module does. And there's a means to calibrate it. Oh, sorry. Oh, so looks like there's some conditioning on the power coming in, and then this is it. It's 2 transistors and a couple trimmer caps and a transformer coil. That's it. This is what all that option 59 is. 500 megahertz output. So even if I got this module or something, I would need to drill a hole into the cabinet, install a new BNC connector, and put a loopback connector. However, if that's all you really need to do is feed in a 500 megahertz signal and that's it, well, I can do that. I can use an RF generator. I have a couple that are capable of doing frequency that high. I just need to figure out what the output level should be and feed it in. It's annoying to have yet another device turned on to make all this stuff work, but in a pinch, until I get a better, find one that has option 59 installed, it should be able to feed in an external signal and make this thing work. If you don't need to do anything else. That's what I don't know yet. Like, are there some jumpers or are there some other things you need to change? But it sure looks like you plop this module in, there's a space for it inside the unit, and you just hook up these 2 lines and these 2 lines, or that goes to that BNC connector, and I don't think you need to do anything else. We shall see. And here's a diagram. Not the greatest quality scan, but here it is. So as we saw inside mine, there's just an empty spot there, which is interesting. So I don't know, from day one when these came out, did they anticipate that this might be needed and they left a space for it, or was this a later thing? And given that it's so simple, why don't they just make this a standard feature of it? I find that kind of curious, to go to all that trouble of making the provisions for it and printing this on there and all that, considering it's just a few transistors and a few parts. Why didn't they just include it stock? I don't know. Now here, finally at the very end, they say when using the 8444A with an 8568, you connect the output back to the input. With a short cable, you just connect these 2 together. So yes, it is official in the documentation that you can use this device with this device if you have this modification, or I hope if you just feed in an external signal. Now something else I needed, the probe, so I don't fry my spectrum analyzer. I decided for now to go with the 1124A. There are other probes, active probes, you can get to have a higher frequency range, and there's some floating on eBay, but there's trade-offs. It seems that if you use the higher frequency probes, they're a little less robust, a smaller voltage range. Then I noticed that Surplus Sales of Nebraska has 1124As for $35 each. So I decided what the heck, I needed to order some other stuff anyways. And if you order $100 or more worth of stuff, you get free shipping. So I just went ahead and snapped one up here. It needs power. That should plug right into the spectrum analyzer. And this will give me times 10 times 100 attenuation and 10 mega ohm input, 50 ohm output, and provide DC blocking. So between all this stuff, we should be able to do some alignment work. Now, I'm going to leave you off here because this video is getting a bit long and I got to do a lot of work in the workshop to play around with this stuff. We will pick up in part 2, and hopefully we will be able to get this 8444A powering up properly and start experimenting with it. That's it for now. Thanks for watching.